Did you know one of the strangest problems in AI today isn't about speed, power, or even intelligence? It's about honesty. I'm talking about hallucinations. Those moments when an AI confidently spits out something that sounds legit, but it's totally made up. And here's the kicker. Hallucinations aren't random bugs. They're baked into the way these systems are trained and tested, which means unless we change the incentives, AI will keep making things up and will keep getting fooled. Today, I want to break down why this happens, what OpenAI's latest research actually uncovered, the real-world risks, and how it's already shaping not just AI, but the internet itself. Because if Sam Altman, the CEO of OpenAI, is saying social media feels fake to him now, you know we've got a bigger problem than just a model making up facts. Let's dig in. Why AI hallucinates. Imagine you're back in school, sitting in a multiple-choice exam. You get stuck on a question, you don't know the answer. If you leave it blank, you get 0 points. But if you take a wild guess, you might get lucky. Over time, if you always guess instead of leaving blanks, your score might look better, even if you were wrong most of the time. That's exactly what today's AI models are doing. They're trained to predict the next word based on patterns in massive datasets. Then they're tested on benchmarks that care about accuracy, whether the answer matches the expected one. But here's the problem. Those benchmarks don't punish confident nonsense, so the models learn to always guess. In other words, AI has been trained to be a great test taker, not a cautious thinker. OpenAI recently put this idea to the test. They compared two models, GPT-4 Mini and a smaller one called GPT-5 Thinking Mini. On the surface, GPT-4 Mini looked like the winner. It got 24% accuracy on a QA benchmark, compared to GPT-5 Thinking Mini's 22%. If you're just looking at the scoreboard, 4 Mini is ahead. But here's the twist. GPT-4 Mini had a 75% error rate. GPT-5 Thinking Mini, just 26%. Why the huge gap? Because GPT-4 Mini almost never admitted it didn't know. It just guessed every single time. GPT-5 Thinking Mini, on the other hand, abstained on more than half the questions, 52% abstention. That humility tanked its accuracy score, but it also made it way more trustworthy. And that right there exposes the real problem. Our leaderboards and evaluations reward bold guessers, not careful reasoners. Now, hallucinations might sound funny in a demo, but in the real world, they can get ugly fast. Take Google's Bard. In one of its first public demos, it confidently claimed the James Webb Space Telescope had taken the very first picture of an exoplanet. Sounds impressive, right? Too bad it was wrong. That mistake wasn't just embarrassing. It wiped billions off Google's market value in a single day. Or look at GitHub Copilot. Developers have found it generating insecure or completely non-functional code while presenting it as correct. Imagine pushing that straight into production without noticing. Even in medicine, researchers have caught AI chatbots inventing medical citations, papers that don't exist but sound totally real. If a doctor, or worse, a patient, trusts that output, the consequences could be serious. So yeah, hallucinations aren't just quirks, they're risks. OpenAI says GPT-5 produces 46% fewer hallucinations than GPT-4. That's progress. But independent watchdogs aren't as optimistic. NewsGuard, a US fact-checking company, found ChatGPT models still spread falsehoods about 40% of the time. Think about that. Nearly half the answers on certain topics were just wrong. And that's in controlled testing. Imagine the scale when millions of people are using these models daily, for everything from school essays to business decisions. So let's step back for a second. Why are hallucinations so persistent, even as models scale up? The answer lies in how models are trained. Pre-training doesn't care about truth. It's just next word prediction. Show the model enough grammar, spelling, and syntax, and it learns patterns beautifully. That's why big models rarely misspell words. But facts? Totally different story. Facts don't always follow patterns. Unless the model saw that exact piece of information in training, it can't know it. It can only guess. OpenAI uses a great analogy. Imagine labeling dog and cat photos by their birthdays. You can have millions of labeled images, but birthdays are random. There's no pattern to learn. The model will never solve that task. And ironically, bigger models can sometimes be worse. A small model might say, "Sorry, I don't know Hawaiian." A large model that knows a few Hawaiian words might overestimate its knowledge and end up confidently hallucinating. Here's where things get really interesting for anyone following AI development closely. Most leaderboards, like MMLU, Massive Multitask Language Understanding, measure whether the model got the right answer. But they don't ask whether the model guessed recklessly to get there. Other benchmarks, like TruthfulQA, specifically test how often a model generates false but convincing answers, and HELM from Stanford tries to look at trade-offs across accuracy, robustness, fairness, and yes, truthfulness. The takeaway? Depending on which benchmark you're looking at, the same model can look brilliant or dangerously unreliable. And because the hype tends to focus on raw accuracy, the nuance gets lost. That's why OpenAI is pushing to change evaluation itself, to reward abstaining and punish confident errors. So, what are researchers actually doing to fight hallucinations? One approach is retrieval augmented generation, or a RAG. Instead of just predicting words from training data, the model pulls in live information from trusted sources, databases, search engines, or knowledge graphs. Think of it as giving the model a library card. Another is confidence calibration. This means teaching models to not only give an answer, but to attach a confidence score, and then training them to be honest about that score. If a model says it's 95% confident, but is wrong half the time, that's bad calibration. Fixing that builds trust. Then there's cross-model verification, using multiple models to check each other's work. Think of it as peer review. One model generates, another fact-checks. Some labs are even experimenting with negative rewards, docking models for making things up, rather than just rewarding correct guesses. None of these are silver bullets, but together they start moving AI away from the always guess mentality and towards something more trustworthy. Now let's zoom out, because hallucinations aren't just technical, they're cultural. Sam Altman, the CEO of OpenAI, recently said something that hit me. He admitted that social media now feels fake to him. He said he assumes posts are bots, even when he knows some trends are real. That's a wild statement. The guy leading the company building these models is saying he can't trust what he sees online anymore. And honestly, he's right. Cybersecurity firm Imperva estimates more than half of all web traffic today comes from bots and large language models. X, formerly Twitter, admits there are hundreds of millions of bots active daily. That's not a fringe problem, that's mainstream internet reality. And it's creating a feedback loop. AI learns from us. Then we start mimicking AI. Sam Altman even said in a Reddit AMA that people now sometimes sound like large language models. Let that sink in. Humans are picking up AI's speech patterns. That means hallucinations aren't just technical glitches. They're bleeding into how culture itself communicates. This is why Altman talks about an authenticity crisis. Because if bots dominate traffic, if models are rewarded for confident nonsense, and if even real people online start to sound like machines, then what does authenticity even mean anymore? It's not just about whether a model hallucinates when asked a tricky question. It's about whether you can trust anything you read, watch, or hear online. And that, in my view, is the real stakes of hallucinations. Not just correctness, but trust. Let's recap with some hard numbers. OpenAI says GPT-5 hallucinates 46% less than GPT-4. But NewsGuard found ChatGPT models still spread falsehoods about 40% of the time. Imperva says bots make up more than half of all web traffic. And X admits to hundreds of millions of bots operating daily. Put those together, and you see the scale of the problem. Hallucinations aren't just an academic footnote. They're shaping what billions of people perceive as reality online. So what does the future look like? Best case, evaluation evolves. Models are rewarded for honesty, not bluffing. Retrieval systems get better at grounding answers. Confidence calibration improves. Cross-checking becomes standard. But worst case, we keep rewarding guess-happy models. Social platforms drown further in bot-generated content, and people lose trust, not just in AI, but in the internet itself. I don't think that future is inevitable, but the direction we push matters. So here's my takeaway. Hallucinations aren't just quirky AI mistakes. They're the direct result of how we've built and measured these systems. And until the incentives shift, AI will keep guessing. People will keep doubting. And the line between human and machine will keep getting fuzzier. Now I want to hear from you. If you had to pick, would you rather use an AI that always gives you something, even if it's wrong? Or one that pauses and says, I don't know? Thanks for watching, and I'll catch you in the next one.